friends, today we are going to solve the question of Karnataka NEET 2013 and the question is the pair of quantities having same dimensions is option A impulse and surface tension, option B angular momentum and work, option C work and torque, option D Young's modulus and energy. When we do in this question, we have to know what each quantity is. What is impulse, what is surface tension, what is angular momentum, work, torque, Young's modulus and energy. If we know the equation to find these quantities, we can easily find out the dimension. If the dimensions of two quantities are equal, we can say that these two quantities have same dimension. Then let's check out what each quantity is. The first quantity is impulse. What is mean by impulse? Impulse. To find out impulse, we know the equation is force into time. We have to know the dimension of force and time. The dimension of force is mlt raised to minus 2 and time is t. Therefore, the dimension of impulse is mlt raised to minus 1. Then next, surface tension. What is the equation to find surface tension? To find surface tension, the equation is force by length. The dimension of force is, we know that mlt raised to minus 2. We know that the dimension of length is L. When L comes to up, L raised to minus 1, L raised to 1, cancel L raised to minus 1, they cancel out. Then mt raised to minus 2. Look, the dimension of impulse is mlt raised to minus 1 and the dimension of surface tension is mt raised to minus 2. Both dimensions are not same, therefore the first option is not correct. Then check out the next option. The next quantity to check out is angular momentum. The equation to find angular momentum is moment of inertia into angular velocity. Dimension of moment of inertia is ml square and angular velocity is t raised to minus 1. If we combine this, we get ml square t raised to minus 1. This is the dimension of angular momentum. And the next is work. Work is force into displacement. Dimension of force is mlt raised to minus 2 and displacement is L. When we solve this, we get ml square t raised to minus 2. Look, the dimension of angular momentum is ml square t raised to minus 1 and the dimension of work is ml square t raised to minus 2. Both dimensions are not same, therefore the option B also wrong. Then check out the next option, work and torque. We already know the dimension of work, ml square t raised to minus 2. The dimension of torque equal to force into displacement. From this we can understand that both dimensions are same. How? Work is also force into displacement. Therefore, the dimensions also be same. The correct answer is option C. Still we know the answer. We have to make sure that the option D is not correct. Then let's check out the option D. The equation to find Young's modulus is force by area by changing length by original length. The dimension of force is mlt raised to minus 2. Area is L square by, right here, delta L is L, L is L. Cancel out. Let's solve this. L square, when it come here, L raised to minus 1, ml raised to minus 1, t raised to minus 2. This is the dimension of Young's modulus. Then find out the dimension of energy. We already know that the dimension of energy is ml square t raised to minus 2. This and this are not the same, therefore the option D also wrong. Therefore the correct answer is option C. The question is done. For more questions, subscribe this channel and thank you for watching.